Get rolling.
Awesome. Welcome, guys. This is episode 17 of season 2 of Baseline Tech Talk Tuesday. And if you're joining us for the first time, I know we had some new registrants last week. So if you are joining us for the first time, you can catch all the replays on YouTube. The channel is Baseline Web Training, and that's all one word on YouTube. And Dan has relabeled much of the previous episodes. So you can look for the season and then episode 1, 2, 3, 4, etc. So you can sort them in order, find the one you want to watch. It's all there for you, as well as new how-to videos. And Dan's got a long list of how-to videos that he's been creating. And I'll just speak for him for a second. He's working on videos to help explain controller messages, because those are videos those are messages that create a lot of phone calls and support and questions. And so Dan's mapping out all of the controller messages in video format to help you. So let's do some quick introductions. I'm Andy Humphrey, Irrigation Technology Consultant line. We have Chris Wright, VP of Sales. We have Dan Conger, our Training Manager. Today, we're going to be talking about conventional wiring. We're sort of at this stage with the business that it's 50-50. As many conventional controllers into retrofit applications as we do new controllers into two-wire situations. And we want to make sure that you understand how our conventional controllers work and how you can use them for retrofits. So with that, Dan, let's hand it over to you.
Beautiful. Well, when I first learned about two-wire, when I was coming through the industry, and it took a while to make it to the West Coast, I was really blown away by the power of two-wire. But what I've heard people say, or I've had this impression that's like, yeah, I can't use a baseline controller because I have conventional wire. So we don't want to leave people out. We want to bring them into the wonderful world of two-wire and all the technology that allows. So we have a couple of solutions on how to bring that onto your site. Mm-hmm. And we don't want to
the other thing that people, kind of tell themselves is they have to go add decoders to the system to use baseline. So they oftentimes think they've got conventional wires and they have to put two together and add decoders and make it two-wire. And that's just simply not the case. So that's what we're here for today.
And at one time, I remember I made a comment to someone before I was working with baseline. I said, well, then we got to run new wire to get a soil moisture sensor. And they're like, well, hang on, time out. So that's one of the things we wanted to talk about. So
yep. So one thing I want to emphasize before we get too far into it, though, and I mentioned it before we went live, that, to us as baseline, this is, working knowledge. And for many of the users in the field, especially if they are new to baseline's technology and retrofitting a site, it can be somewhat confusing. So we want to make sure that you all walk away today with a clear understanding of how we're able to interface with conventional wire using baseline's two-wire technology.
Sure. So the first thing that I want to make sure that we cover is it's kind of a basic thing, but I think it's worth mentioning is conventional wire. So Andy, would you spotlight me for a minute? So here I've got a bundle of conventional wire, and it's just a bunch of number 14 wire. And what's different about conventional wire is, so we've got this common wire that runs, it's the loop back, and then we've got these station wires. So this is a bundle of 20. I've got 21 wires, so I can run 20 zones off of this one. This number 14 wire could be smaller, could be larger. So there's this conventional wire, and this is what we're talking about addressing. And the big difference between two-wire and conventional is, if you look at two-wire, of course, you got a different physical appearance. There's a physical cable itself, right? So this has got this perhaps a similar or same wire, different splice or more important splice, but it's got this outer jacket that's quite durable, that high-density polyethylene. And so we've got the physical differences. But then there's the difference between what they do, right? So a two-wire is going to carry power out to the zones and data. And for the most part, the conventional is just going to be carrying power. And I'm saying there's an exception coming up in a moment. So the one thing I really wanted to catch on this one is well, I've got a bundle of 20 wires. Oh, I need two wires. Cool. There we go. I got a two-wire cable. No,
not advised.
Ill-advised to make an understatement. And I think the biggest reason for that one is that PVC, some of this wire can be PVC's jacketed, and that's porous. Water into this wire path can corrode these. And I'm sure many of us that have worked on conventional wire system have stripped back a wire and seen that black corrosion on the inside or the outer jacket, the outside of the copper inside there. That's corrosion.
Yeah. And when you mentioned data, Dan, we're sending data, but it's also going in two ways. It goes out to the device and then it comes back. And so if it's going to make a round trip, there needs to be better integrity. Otherwise, it could drop off at some point, usually on the way back, and then it reports as an error.
Right. So data here, data and power, generally just power, and that corrosion isn't necessarily as big of a deal for power. It's a big deal for data. So that's probably the single biggest thing that I'd like the warning I'd wanted to start with on all this. So how do we deal with that existing wire? It's all about our powered bicoder. So let me switch my camera over, and this is the magic right here, right? A power bicoder is how we address conventional wire. And what we've got here is we've got a series of terminals that will connect to the conventional wire path. So, these guys will come in and fan out and connect onto that one. We've got a couple of extra terminals here. I've got a rain jumper, and I've got a 2-wire terminal. So I can actually extend a 2-wire. So I can run, this is 24 zones of conventional wire. And then I can also pick up that other 196. No, that's not right. Someone do the math for me. The additional zones up to 200 zones off of this 2-wire path. So I can run, this can be a hybrid, conventional and 2-wire off of this board.
So why is it referred to as powered, Dan?
So this is essentially a bicoder that's got, this particular one has 12 and 12. So this is essentially 24 zones of bicoder, but it needs a power source. So this little cable here that I'm using to keep the shine off of my ring light, this is a power cable that might need to be, depending upon your installation, you might need to use, or we need to get power into this terminal from the controller. So it's actually energized and needs a power source in order to run this, because there's circuitry on this one.
And let's talk about the why. The difference between this bicoder and let's say 4-station bicoder is the distance from bicoder to solenoid.
Yeah, right.
So on a standard 2-wire bicoder, I think 150 feet. Is that right, Chris? Something like that?
Yeah, that's the maximum.
Maximum.
Recommended 100 feet.
And so on the powered bicoder, you have your traditional wire length runs of conventional wire based on 14 gauge or 12 gauge or 18 gauge, because we're powering it directly at the board with 24 volts.
Right.
Correct. Yep.
So I brought in a single zone bicoder so we can see our code on there. And I wanted to show you this because there's two things about this one. So this is going to connect onto the 2-wire path. So I refer to this as the 2-wire side. And the output, so the common and the zone wire, goes to our solenoid and our valve, right? And there's perhaps typically on this, there's usually a very short wire path, but we've taken this bicoder and put this technology into this board. So that what's important about that one is this is essentially a 12-zone bicoder, or 24-zone bicoder, pardon me. And everything that connects to this terminal is the solenoid side. So we've got the wire path coming out, the solenoid, and then the common coming back in. And that's all solenoid side. So while on a 2-wire system, we may get messages or errors, depending upon, about 2-wire issues. And I can also get status about my solenoid side, the solenoid itself. Any messages I get on a powered bicoder are only going to be about the solenoid side, because the 2-wire path is what's really short. It's an inch long, and the likelihood of seeing a 2-wire issue on this board are really, really slim.
It can happen.
Yeah.
Right. It can.
Keep in mind that there is a 2-wire path that connects that board to the controller that facilitates two-way communication and allows us to operate that conventional wire using our two-wire technology.
Right.
So that's how we do search and sign the same. That's how we get soil moisture sensor data back. All of those things that we enjoy on two-wire, we can do on conventional wire as well. And it is using two-wire technology to do it.
And I've got an example where we're going to move this outside the controller, and we'll look at that in just a moment. So with this board, now we can run conventional wire. We can connect to existing wire, existing solenoids. We can also bring in soil moisture sensors on with this board, and we can do that using the common and the station wire at the valve or into the valve box that's nearest to the zone we're trying to irrigate. So that's the one I said. Conventional wire is generally power only. Well, in this case, we're actually running some data over that conventional wire for the soil moisture sensor, and that's about the only thing that really works over that. So a couple of things that are important to remember on when a soil moisture sensor comes in. There's one or two unique terminals. So A1 and A2 are very specific, and B1 and B2 are very specific. They're unique and they're different from the other terminals.
Why?
Thanks. Excellent question, Chris. Those are the only two on a bank of 12 or the two on the bank of 24 that the powered bicoder will look for a soil moisture sensor. So if I attach a soil sensor to B8, it will never look for a soil moisture sensor. It doesn't have the capability. It only has the capability of checking these two terminals to see if there's a soil moisture sensor.
Yeah. And when one way to think of it is when you run that search on the controller for search and assign, it also includes those ports, A1, A2, B1, B2, but it's not looking for anything else other than the moisture sensor. So you cannot hook up a flow sensor or any other baseline two-wire device to those, just moisture.
Right.
Although I've never tried it. Maybe we should, Chris.
That's not entirely accurate, Andy, because you have the wire from the valve that the moisture sensor is wired to in the field coming back to A1, A2. So you've got the solenoid as well as the moisture sensor.
Oh, that's true. Yeah.
On that post.
Good. Excellent point. Yeah. Right.
Okay.
So in
order to read the sensors, just so it's clear, the wire coming from the valve that the moisture sensor is wired to has to land on post A1, A2, or B1, B2. So on a 24 station conventionally wired R board, you can have 4 soil moisture sensors attached to it.
Correct. Right. Now a 3200 can handle up to 25 soil moisture sensors. Well, we can't quite fit that many on this board, so we'd need additional boards to do it, but it can be done.
Or it can be done on the 2-wire path too.
There we go. Right. So typically this is, I've got this set horizontally. Typically it's set vertically and it's mounted on the side of the controller. So let's look at what it looks, let's take a look at a couple controllers inside, and I'm going to switch back my camera.
And it can be, I think on pedestals, it's the other way. So it can be either or.
Oh, is it? Okay.
We've got them right side, left side, bottom up, top down.
Right. So here's an installation of I believe this is a 3200, and it has 2 banks of 24 mounted inside. So this came from the factory, ready to receive 48 zones of conventional wire. And then it has the option of connecting a 2-wire path onto it to run any additional zones. Well, this particular site had close to 200 zones conventional already there. Well, this box can't handle it. So they needed a way to pick up those additional zones and another 150.
So that enclosure could not support
there we go.
all of the conventional wire. So
Excellent.
the box itself, the controller supports it, but the enclosure couldn't accommodate that much conventional wire.
Right. Now, the person that installed this is an electrician, and we still Chris and I still gush about him. He had just this wonderful installation. And now if they had larger wire, it could be a real nightmare trying to fit too many wires in there. And I think that's just the physical limits of getting wire and spares into that box. That's what it's about. But the controller, to Chris's point, can still handle more. So this is what he did, is he set the controllers at the top panel. And then he has three other cabinets, X cabinets, with 48 zones of conventional wire boards in each one of those. So now he has 190 some odd zones of conventional wire that he can run, nearly utilizing all 200 zones, the 200 zone capability of the base station 3200. And what was really nice is he had that really large cabinet on the right that was already there on site. So he did all of his major wire work coming in from the field there, and that really lent to the very nice, clean, and quite anal retentive organization of wire.
Which is what we love to see. How did he connect all those boxes together?
So he used a 2-wire path between those. So if we I'd mentioned on the powered bicoders, there's also a 2-wire terminal. Well, that can put 2-wire out, but it can also bring 2-wire in. So essentially all he did was just run a short leg of 2-wire path between the base station 3200 and the first cabinet, and then to the next cabinet, and then the following cabinet. So there's no need to actually have those wires together to actually move all those wires. And I think that kind of lends itself well when if you're replacing multiple controllers in close proximity, but not right next to each other. There's no need to move all the physical wires. We could just put 48 zones on a 2-wire path and then bring them back into the controller.
Yeah.
So
one way to look at that.
How could we do this wirelessly without a 2-wire path between each box?
Sure. Well, that's the textbook definition of a substation right there. Yeah,
exactly. So
if we didn't have the ability to run this jumper wire between those two, a substation would do exactly that, right? That's how I think that was the impetus for the substation is I can't get a wire from here to there to run a powered bicoder in a cabinet. How can I do it? And that's a substation.
Exactly. Nice. Yep. All right. Very good.
So I like this installation too. This is a great example of this is one you were involved in with Chris. And you want to tell us a little bit about this?
Yeah, absolutely. So we went into this park site to upgrade the technology to something more modern. And the beauty of our ability to accommodate the existing conventional wires, it allows us to use a lot of the already built infrastructure for the irrigation system. So all we had to do in this instance is replace one of the pedestals with a base station 3200. And then in each of the other 4 square top pedestals, we simply removed the faceplate and the boards associated with the previous controller and laid in a powered bicoder into that tray and wired up all the existing wires from the zones that came into the sweeps into those pedestals onto those R boards, and then powered the R boards off the existing transformer that was already in the pedestal, right? So we were able to use the power, the stainless, the wire associated with the previous control system without all of that added cost. So in this instance, we took about $70K worth of irrigation equipment and retrofitted it for like less than 12.
Yeah, I was going to say it's probably about 10% of the total price.
Yeah,
if you were to do it all new pads and everything.
Yeah, because the stainless is still good. The transformer's still fine. The grounding hopefully is still okay. You don't need a new concrete base.
Absolutely. Yeah. So, and then, each one of those conventional zone wires was numbered So we knew what zone it was in the previous control system. So wired it up, and then we were able to do the search and assign and make sure that it's kept the same configuration for management and programming. But in essence, we could have mixed those zones up any way we wanted to in order to make it work. So on this site, it was, I think, 178 zones that we consolidated into one controller interface.
Mm-hmm. So the image on the right, that power bycoder has a specific model number, but what's a little slightly unique about that, it has that power cable, which will connect to the transformer, and then it has a backing plate with little standoffs that just gives you, the contractor, the ability to mount that, right? Because you can you could put that in a plastic cabinet, in a stainless, in painted steel, whatever. But now you've got that backing plate, because the one I was showing you before has soldered back ends, right? And that would, up against stainless, that would not end well. So it just gives you some flexibility on mounting that. And I realized when I was looking at through my supplies that I didn't have the PCK powered bycoder. That's that. What is that? Pedestal
Conversion
something
kit, which is what we're looking at right there.
Right. I didn't actually have that particular model number. So I ordered one from the factory and they sent it to me, and it actually came with the drill bit and some cutting oil. And I was like, wow, just about almost everything you need. You just have to have, a little bit of skills as a contractor to figure out how to mount it. You wouldn't want it flopping around loose.
Yeah.
So I really think that PCK conversion is really works well, and that's actually that's how that first project that you and I worked on when I worked distribution, we used exactly this type of style and left the cabinets, and that was a big factor, a big cost saving factor.
Yeah. So I don't know, Dan, there's two things I'm thinking about that we should mention, and they may be you have planned for the last 5 minutes here, but we should mention that they have serial numbers, that they're addressable, just like any other decoder.
Excellent point.
I was going to bring that up. What is the serial number, sequence or nomenclature associated with the R boards?
So while the convention, 2-wire, they start with D, E, or Q. That's the serial numbers for zones, single zone, 2-zone, or 4-zone decoders. All conventional wire starts with a VA or a VB. So this one is actually right here. It has the sticker and it starts with a VA, and then that's the series. And this is VAH 3901, 3902, all the way down the line. So these are VA and VBs for conventional wire.
And then each screw terminal, right, has a specific address, and you can mix and match and reorder. So it might be that that's a bank of 12 or 24, but you can put them in any order that you want to, that you don't have to have them be in that physical setup that comes on the board. You can reorder them in the controller however you want to. And I would encourage you to take notes, because you can easily get yourself down lots of holes and not know what the heck you're looking at if you're not careful. But you can then set it up the way that either you or the user wants it to be set up.
That when I had a mind blown moment when that first occurred to me, that you don't actually have to move wires to change the order of them. You just assign them in the order you want. Like, wow. Which is it's a shift.
What's the purpose of that? Why do we do that?
Well, it could be for a couple of different. Well, it could be for that. Maybe you're doing it to pick up the soil moisture sensors, but maybe you're doing it for order of zones and the way they irrigate the property.
Yeah, you can hydrozone the controller the way you want to and group like zones together associated with the soil moisture sensor using that flexibility of search and assign for those conventional wire posts.
Right.
Yep.
Excellent.
So we've got a question that came in from Mr. Newberg. When converting a conventional system with multiple conventional control timers, would you need to maintain station wires with their dedicated common wire?
That's been a point of conversation recently.
Yes, you cannot cross commons, right? So you got to make sure that commons aren't connected anywhere in the configuration or how it's wired up to those boards. Because if you do create those common crosses, it's going to create a no worky scenario.
Yeah, and it might be per transformer too. I think there's something more to it that we may not be able to clarify per se, but best practice is to do exactly what Chris said.
Yeah. And there's no need to connect boards together with common wire. Right. So that's all facilitated on the 2-wire side. So you've got bundle wires coming in to an enclosure. You wire up the commons to the board, and then the 2-wire path connecting them back to the 3200 will facilitate the management of that so that it doesn't create a conflict or a short or smoking controller or any of those fun things that could happen. So on that conventionally wired board, you've got VA001 or VB001. What is VE?
Well, let's see. We've got
zones.
What's master valves, right?
Yeah, exactly.
Or station zone, or it's just two spare addresses on a board. So you either have 14 or you have 26, station count board. And typically that would be for a master valve or a pump start, or
but you can
2 extra zones. If you have 25 zones that you want to convert, you just need a 24 station board because you've got extras.
Right.
Yeah. In most cases.
Yeah. Now on those screw terminals on the end that for the 2-wire, right? So this is the good part, right? So we've got other cool devices. So I've got a pressure component, a pressure sensor. I've got a precip sensor. Other things that I want to bring into my system, I can actually mix and match. So I can run 2-wire and conventional all off that same board, off the same system. So that's the same controller, right? Whether it's 2-wire or conventional, it's just let's bring those sensors in. You may need to run a dedicated section of wire to bring that device in.
And when you only have conventional wire, it's oftentimes helps to clarify by calling the 2-wire port the COM port. If you're not using it for zones, it's just where you hook up your communication devices, flow sensors, pressure sensors, precip sensors, moisture sensors, anything that you want to communicate to gets connected to the 2-wire port.
Yep.
Beautiful.
So another question came in from Stonk at Westminster. Would the black corrosion on a conventional wire inhibit the connection to a moisture sensor?
Possibly.
I would say I wouldn't
probably wouldn't inhibit the connection. The wire would probably see the soil moisture sensor, but it may not be able to pass data back depending on the severity of that corrosion.
Yeah. If you want to search and assign and you're not seeing the moisture sensor, it could be one splice or multiple splices that are all just slightly corroded like that compound over time.
Yeah. And probably the most frustrating scenario for that one would be intermittent communication. That would that's a hard one. So yeah, it has a possibility of it for sure.
Yep. All right. So we've blown through our 30 minutes. We're at the bottom of the hour. So I believe next week we are taking a Memorial Day week break, correct?
Yeah, that is right.
We will be back first Tuesday in June
8th,
for another exciting episode of Tech Talk Tuesday. So we appreciate everybody that joined us today, and hopefully you learned something. Hopefully we shared some clarity as to how our conventional wired products work, or maybe we created some more questions that you want to follow up with, either calling your RSM or getting back in touch with Dan as Ask the Trainer, or through support. So we appreciate your support of the technology and the products. We're here to help you be successful with them. And please help us to help you in that effort. So we're going to drop off. Thanks, everybody. Go out, have a good week, work hard, be safe, and we'll see you after the 1st of June. Have a good Memorial Day weekend.
All right. Take care, all.
Bye-bye.